Okay, so now we are going to try and understand the different data types that is supported in Pandas, and we will be trying to print out the different data types here. Now, D types is a property that is accessible from the data frame. So if we wrote this extra line here, that is print df dot D types. So we are accessing a property here. Now this property will tell us the data types of the data frame, that is that of the columns in the data frames, I'm sorry, of the columns in the data frames for each one of them. So if you recall earlier, there was a fruits column, a size column, and so on. So we can find out what's the type that is inferred. Okay, so technically when Pandas loads the data into the data frame, the data types are inferred. Okay, so there's a inferred, meaning it just tries and understand from all the data inside what is the best type that will match that data in a particular column. Yeah. Okay, so that's what happens. Now, this inference is good and bad. Yeah, the good part is it's automatic, so you don't have to go and declare the data type for each one of them, saying that column A should be integer, column B should be float. Okay, so if you were to do that, I mean, if you were to do that here when you're reading and then you go and write all the data types, you can imagine how long uh, this particular method will become, and it'll be a bit more troublesome. Now, this automatic behavior actually is quite a time saver and a very useful feature, but at times it can go wrong. Yeah, at times it can go wrong because machines. I mean, the design is not to predict at 100% accuracy. It does its best based on the data. So what is given to it, it will try and infer. But the person who is actually working with the data type, that means the human, will tend to know what this data should be represented as in a much better fashion. Yeah. So you and I will know the data much better, whether it should be an integer or whether it should really be a float, for example. Okay. So this is how we print out the data types. All right. So if we run this, now we are going to get, now the earlier print statement here on line 5 prints out the table here. And then in line 8, it prints out the inferred data types. Yeah. So for example, the fruit column, the data type inferred is object. The size column, the data type inferred is object. The color column, the data type inferred is object. The unit price column, the data type inferred is also object. And the quantity column is only different here. It inferred it as an integer 64. Yeah, or integer. All right. So when we look at the data here, 2, 1, 10. Okay, now this is very clear, right? It's a clear set of numbers. So given these 3 data points, Pandas was able to clearly know that this data should be integer. Yeah. And all the rest are very general types. They are called objects. Okay. So Pandas classified fruit, size, color, and unit price as objects. All right. So let's go. In order to understand what Pandas can classify, we need to understand what is available. So the question is, what data types are there in Pandas, or what does Pandas support? Yeah. Okay. So we wrote a small table of some of the data types that is supported in Pandas. So the first data type, and the first column here is the data type, the Pandas data type, and then we have the corresponding Python type and a bit of explanation. Okay, so on the first data type, we have an object here. Yeah, so an object is a general representation in Panda. Yeah, it can be containing of strings. Now, a string, if you recall from your primitive data types, or if you've used a string before in other programming languages, a string just contains values inside quotes. Yeah. Yeah. So whatever we write with numbers or with special characters, yeah, this is an example of a string. Yeah, which is inside 2 double quotes or single quotes. Yeah. So it can be what we call of type text or mix numeric and non-numeric. So this sort of data is represented as an object in pandas. Yeah. Now the other type is integer. Integers are whole numbers, yeah, which can be negative and positive. So whole numbers are anything that are like 32, 64, 64 and so on, yeah. 108 minus 2, yeah, without a decimal point, yeah. Okay, the third type that is supported is float with a small f, yeah, because there's type sensitivity. I mean, there's a letter sensitivity, sorry. So float and int is the small I. Okay. So float, yeah, float are decimal point numbers. Now bool. Bool is values that are true or false, yeah. Just two logic levels, either true or false, yeah. So we can store these values into bool, and that's about it, yeah. Okay. Now date time is another category that handles different sort of the date and time configurations for a particular entry. This is going to become very important for the IoT environment, yeah, because we have sensors that always send data based on time, yeah. So time is an important thing when it comes to IoT data. All right. So later on, we'll be looking at this quite often, time series and so on. Now the last type is quite a unique type to pandas. Yeah, it's called category. Now category is a type that is created by that is available in the pandas library, which is used to represent a finite list of text values. Yeah. Now what is a category? A category is a type of value that is always repeated in your data. Okay, so in order to understand what is a category, I'm going to look at the data again here. So, for example, we have a table here, right? Okay, and in the first column, we have fruits. Now, fruits can be quite wide and there can be many different types. Definitely, there's a finite amount of fruits, but the list is so big that we can go from apple, watermelon, orange, and the list can build on. Yeah. So this can or cannot be a category, but generally speaking, since the list is too big, we might not classify them as a category. Okay, so usually these values are better represented as objects. Objects. So fruit being an object might be the best choice. Okay. It also depends how you want to tell your story on your data or how well you understand your data. So this is my explanation for this column. Okay. Now size is I don't think there needs to be a size. I think it's quite clear in this case. We are only using a very finite level of classifications for size, whether it's small or large. So if you really understand your data, for example, there's only 3 data points and the size can either be small, large, or if you already know that there's only 3 values, let's say small, medium, and large, we can represent size as a category instead of object. Yeah. So that would be the better choice. Yeah. Instead of an object, we can represent size as a category because categories is finite, right? Remember? Yeah. It's a finite list of text values. Yeah. Size can be small. Sorry. Size can be small, can be large, can be small. Okay. So if let's say we already know, okay, size, the type of data that we're going to find here is definitely only 3 values, either small, medium, or large. So if we know that there's a finite list here, the best representation for size should be category. Yeah. Now converting the object to a category will allow your data to be better managed. Yeah, it will load up faster. In this case, you see this data is very small. Yeah, there's only 3 rows here. What if we have a million rows? Yeah, that's when this sort of classifications become very important, or 2 million or 3 million or 10 million data sets for a global fruit supplier. Yeah, so that's when this sort of classifications become very important from object to category so that your data can load up faster. Okay, and now color, let's say we know there's a finite there are a finite number of colors, so color can also be best represented as a category. Price, if we think that the prices are highly variant, the best representation of this can still continue to be an object. But of course, there is something funny here. Price is usually a number, right? Price is usually a number. So if it's a number, we see a decimal point number, 0 0.6, 2.0, yeah. The better representation of price should be floats, FLOAT. But since there is a dollar sign here, Pandas couldn't infer this directly to be a float. So we might need to do some processing in the later parts. And that is where we do data pre-processing, where we say that actually we want unit price to be a float so that we can do some calculations. Yeah. Okay, what type of calculations? Right now we got the unit price and the quantity. Can I find out what's the total cost? Yeah. So I can take the unit price times the quantity. I'll get the total price, right? So, but in this case, since it's an object, it might not be easy to work with. Okay, so these are some of the things we will be doing in the later stages, yeah, and we will show you what is the problem when we use the default type here as object. All right, okay. So, and this concludes the different types of data types supported by Pandas.